All right, this is checkpoint 5, exponents. Now, we started off this exponents earlier this year when we were looking at having a bunch of exponents or a bunch of variables being multiplied and labeling that as, let's see, we have 5 x's here. This is x to the 5th, right? This is kind of what we're looking at. They are not being added, okay, no addition. When we have exponents, they are variables or whatever the base is being multiplied. So let's go over something very quickly. We have, this is the base, okay? It can be a number or a variable. And then this little number hat on top is an exponent, which could also be or a variable, okay? The exponent tells you how many bases there are being multiplied. Okay, so for instance, number 1 right here, this is really 4 x's being multiplied, right? With this extra x being multiplied to it. And then how many x's do we have? We have 1, 2, 3, 4, 5 x's. This becomes x to the 5th, right? However, it can be tedious to do that for every single one of these problems. I don't want to have to write out a bunch of 3's. Like, I am not doing that. That is too much work, okay? So what we're going to do instead is we have exponent rules down here, okay? These exponent rules tell us about the nature of exponents so that we can just follow these rules rather than spreading out all of our bases and exponents and such. So our first rule, anything to the power of 0. X means anything to the power of 0 is 1. Okay? So this could be 4 to the power of 0 or 9,000 to the power of 0 or smiley face to the power of 0. These are all equal to 1. Okay? Anything to the power of 0 is 1. Now, when we have multiplication, x to the a times x to the b, it doesn't matter what a and b are, but as long as they are the same base, okay, this is going to become x to the a plus b. We are allowed to add the exponents. So when we have multiplication, we add, okay? Then for division, when we are dividing two exponents, okay, this little fraction bar means division, we are allowed to subtract the exponents. Okay, so we would have x to the a minus b. This is subtracting the exponents. Then when we have an exponent to the power of another exponent, okay, what we're going to do here is we are going to multiply our exponents. So x to the a times b. And then when we have a negative exponent, what we do is we put it on the bottom of a fraction. Or if it's on bottom, we put it on the top of a fraction. So this is really over 1, right? We can divide anything by 1 and it stays the same. So we bring it down to the bottom, and this becomes x to the power of a, and now it's positive because it's on the bottom here. X to the power of a on bottom, okay? Now, usually for these rules, you need the same base, right? So if you have x to the a, let's say, times y to the a, or to the b, okay? These are not the same base, not the same base. So we can't use any of our rules to combine, okay? So focus on the bases. They have to be the same. Otherwise, this is pretty much all the rules you will be using. Maybe just a quick extra rule here. I'm going to say extra rule. Anything that looks like it doesn't have an exponent, like a number, really has an exponent of 1, okay? It's like a secret 1 exponent. Anything that doesn't have an exponent actually has an exponent of 1. So if you have just a y, it really has an exponent of 1. If you have just a 7, it really has an exponent of 1. So if you see anything without an exponent, it truly has an exponent of 1. Let's just do one problem together here, okay? I have 2 to the power of negative 5. I already know that this 5 is going to need to go on bottom of this fraction. So this is going to be 1 over 2 to the 5, okay, times, now remember, here's the secret rule. If it doesn't have an exponent, it is 1. So we have times 2 to the 1 times 2 to the 6. Now, these are being multiplied here, so we can add them. So this is 2 to the power of 7, and this is still times 1 over 2 to the power of 5. Now, this is like a division problem, right? So this is really 2 to the power of 7 over 2 to the power of 5. Same base, they're divided, which means we could subtract them. So this is 2 to the power of 2, which is 4. Okay? Another way you could have done this is just add all of these exponents. You could have done 2 to the power of negative 5 plus 1 plus 6, which is going to get you 2 to the power of 2, which is 4. Okay, so sometimes there's a couple of different ways that you could do problems like this. And that is all.